There are two types of logs that show up pretty often in real-life applications: the log with the base 10 and the log with the base e. Now remember that e was a number that we defined previously as 2.7, roughly speaking. So turns out that this shows up very often, problems with log and the base e. So instead of writing log base e every single time, people decided, let's replace that with ln. So when you see the letters ln, you should just realize that this is natural log, or in other terms, it's the log with the base e. So it's a special kind of log. Similarly, there's another one called log without a number. So what does it mean to write down log without a number? It literally means log base 10. So kind of like when we write square roots, we don't put the 2 there, it's implied. Similarly, we do the same thing with log. So if there's no number written in the base, you should remember that the number is basically 10. Okay, so these are just kind of like shortcuts that will help us save a little bit of time so that we don't have to write down the full notation basically. Okay. Now the same properties that you already know about logs will apply when you're working with natural log. So this table that you're seeing over here on this page is pretty much the same table that we had previously discussed together. The only difference is instead of writing log with the base a, we're writing ln. So it's basically a special log with the natural base e. So all the formulas are pretty much the same as before: the product rule, the quotient rule, the power rule, and then the rest of them are pretty much identical. Now, how do we use this log thing in real life? So here we go. Let me give you an example. So sometimes we come across problems like this: e to the power of negative 0.04t is equal to 0.05. And this kind of problem will show up when you're talking about exponential decay or like radioactive decay, or if you're talking about investments, you'll come across problems like this. So as you can see, we're trying to solve for t in this problem, and t is in the power in the exponent. So we would like to get it out of the exponent. So in order to do that, we have to involve rule number 3 from the list before. The rule basically says you can swap the power to the front. Now the only way to do it is if you have a natural log in the problem. This problem does not have a natural log, so what we're going to do is basically this. We're just going to throw in an extra ln on the left side of the equation, and whatever you do on the left, you're going to do the same thing on the right. Okay, so by doing that, everything is pretty much staying balanced. And the log allows me now to take the power, the negative 0.04t, and write it first before the ln with the e. Okay, so that's what the rule number 3 basically says. Now on the other side, we have ln of 0.05 and whatever, we don't care. So at this point, remember, we are looking for t itself. So we have to somehow get rid of all the numbers from around the t. So first of all, what is ln of e? According to the rule number 4 from the table, ln of e is really just the number 1. So this is now saying negative 0.04 times the t times the 1 is equal to ln of 0.05. And again, we don't care what that number is. It's just something that the calculator is going to give us in a minute. But we would like to know what t is. So at this point, I'm going to try to get rid of the 1 and get rid of the negative 0.04. And I could do that by division. So they're being multiplied. So in order to remove them, I divide by negative 0.04. And then times 1 is not going to make any difference. We could just write down negative 0.04. So this is what we call the exact value, or what's the approximation. So look for the ln on your keyboard and then hit ln 0.05, close the parentheses, and then divide it by negative 0.04, and let's see what happens. If you notice, I would get 74 basically 0.8933. Let's round to 4 decimal places with these problems. So 8933. Okay, so the first one is the exact value and the second one is the approximation. They're both valid, they're both acceptable.